Hello guys, trust you're doing fantastic. In today's video, I'm going to be solving two exercises as relate to the conversion from hexadecimal to octal number system, as well as octal number system to hexadecimal number system. All right, so the question says if 11x1y into bracket base 8 equal to 12c9 into bracket base 16. It says find the values of x and y. Now all we need to do is that we need to look at this equation from both sides across the equality sign. So on the left hand side, we have two unknowns, which is x and y, and they are in octal number system, that's base 8. And then to the right, across the equal sign to the right, you have a base 16 number system, and then you don't have any unknown. It means all the digits in the right side of the equation are all known. So it means that we need to start solving from the known to the unknown. So solution will be that we would say that 12c9 base 16. So the first thing we need to do is to convert this to base 2. We have to convert base 16 to binary. So this is what we need to do. We have to convert first to binary. We're converting base 16 to binary. It's going to be what? It's going to be 8421. So this is the code. All right. So for 1, it's going to be 0001. For 2, we're going to have 0010. For C represents what value? So since C represents 12, that will be 1 1 0 0, and then 9 is 1 0 0 1. So since we have the binary equivalent of this expression in hexadecimal number system, now we need to go ahead to convert these binary values to octal, because in the equation you have the left side of the equation is base 8 and the right side of the equation says base 16. So since our destination is base 8, so we have to use the relationship between binary and octal. So this is octal. So the relationship, the number of bits required is 3 bits. So it's 421. That's a 3 bits that is required. So in this case, we need to do grouping and padding. Since we don't have decimal points, we're going to do grouping from the right to the left, and we're also going to do padding towards the direction of the left hand side. So let's begin the grouping and padding. All right, so we have 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. So we have 1 0 left. So since we have 0 left, we need to do padding. So we pad with 2 more zeros so that we can have a complete group. Okay. All right, so let's see what are the equivalents of these binaries in octal number system. So 0 0 0 is going to give us 0. 0 0 1 is going to give us 1. 0 0 1 is going to give us 1. 0 1 1 is going to give us 3. 0 1 1 3. 0 0 1 is going to give us 1. 0 0 1 is going to give us 1. So therefore, now the first 0 is going to be omitted, not significant. 0 before the digit 1 is not going to be significant, so we eliminate the 0. So we're left with 1 1 3 1 1. So therefore we can say that 1 1 3 1 1 base 8 is equal to 1 1 x 1 y base 8. So since we're asked to find the values of x and y, so in this case we have the same value as 1 1. So the missing value, which is x, so x is equals to 3, right? And y is equals to 1. So this is pretty very easy. All right, so the second example I want to look at is, so the question says find the unknown value in the relation. So we have 2.3 base 4 plus 1.2 base 4 equal to y base 4. So it says find the value of y. So y is the unknown value in this relation. So if you have an equation like this, the first thing you need to do is to convert the left hand side of the equation to a base 10 number system. So the first thing you need to do is to convert the left hand side of the equation to base 10. So that's pretty very easy. So all we need to do is to bring this out. Base 4 plus 1.2 base 4. So we have the place value. So this place value for the value before the point is going to be 0. While the place value for the digit after the point is going to be -1. Same way 0 minus 1. So let's express this out. So we're going to have 2 times 4 raised to the power 0 plus 3 times 4 raised to the power -1 plus 1 times 4 raised to the power 0 plus 2 times 4 raised to the power -1. So in that case, we will have to simplify everything. It's going to be 2 plus 3 over 4. Okay, so this is 4 raised to the power 0 is something as 1. 1 times 2 gives us 2. Now you have 4 raised to the power of -1, which is something as 1 over 4. So 1 over 4 times 3 will give us 3 over 4 plus. So we're going to have 1 because 4 raised to the power 0 is 1. 1 times 1 is going to give us 1 plus 4 raised to the power -1 is something as 1 over 4 times 2 will give us 2 over 4. So if we go ahead to simplify this further, we're going to have 2 plus 1 will have 3 plus. These are fractions we need to carry out the division. So we're going to get 0.75 plus 0.5. Now add everything up together. We're going to get 4.25 base 10. Remember, this is base 10. The final destination is actually base 4. So since we've converted this to base 10, which is the first thing we need to do, then from base 10, we need to convert to base 4. And then so that we can finally derive the value for y. Now, for we to convert this to base 4, remember the technique, converting base 10 to any other number system, we need to divide and multiply. So we divide only when whole digit without decimal point, and then when we have decimal point, we have to introduce multiplication. Now for this value, this decimal value that we have includes or has a decimal point. In this case, we have to break this number into 2 parts. The first part will be the digit before the point, and the second part will be the digit after the point. So for the first part, we have 4. So let's say 4 base 10. So let's convert this to base 4. So what we'll get is we'll have 4 and 4. That's 4 divided by 4. So 4 into 4, that's going to be 1, remainder 0, right? 4 into 1, this is impossible. So it's going to be 0, remainder 1. So we can start the result from bottom to top. So therefore, we're going to have 4 base 10 will be equal to 1, 0 base 4. Now the other part, which is the second part, we're going to have 0.25 base 10. Okay, what will be its equivalent in base 4? So all we need to do at this stage, we need to apply multiplication. So we say 0.25 multiplied by 4, which is the radix value. So if we do this, what we're going to get 1.0. Now by law, it says that we have to take the digit before decimal point. And then for we to get the value we need to use for the second round of multiplication, we say 1.0 minus 1. That will give us 0. So 0 times 4, that will give us 0. So at this point, you can have 0.0. So at this point, the law says take the first value that you have. All right, so if you take this first value, we're going to have 0. Okay, so at this point, you can decide not to even continue anymore since you have the final value to be 0. So by convention, once you have the multiplication value to equal to 0, you necessarily don't need to continue anymore. So you can actually stop because the 0 will necessarily not really be significant. So you can actually stop at this point. So you can actually stop. Don't consider this. You can just stop at 1. All right. So in a nutshell, 0.25 base 10 will be equal to 1 base 4. Okay? You can say 1 base 4. So therefore, 4.25 base 10 is equal to 10.1 base 4. So therefore, y is equal to 10.1. So that is the solution. So this is the end of today's exercise. Pay attention to the subsequent videos in this channel. Enjoy this video. Bye.